Hello, everyone. My name is Sayak. I work as a research engineer at Hugging Face. I work in areas like image generation and video generation. I want to start by giving you a note of thanks for coming to my session. It's funny, my session, because I was looking at the list of the sessions for the day. And I think mine's the only one that talks about some visual stuff, image and video generation. So I guess I'm particularly very excited to be able to present this to you today. As for the talk, I'll try to keep it very lightweight so that we have more rooms for questions and answers and what lies ahead of us in terms of the possibilities. With that, I'll start. And this is roughly how the outline of my talk's gonna look like. I'm gonna start by showing you some examples as to what today's open video generation models can do, and discussing a bit about their current possibilities and how we can extend some of their possibilities through simple things. We'll also talk about a bit of limitations, so in case if you want to sort of work on them, or if this sparks some interest in you to work on them. If there's time, we'll do some Q&A, but I'll be around throughout today, so feel free to catch me if you have some unresolved questions. Now, before I go to my slides next, I want to quickly know my audience a bit. How many of you are aware of Hugging Face, the name? Okay, almost every one of you, so that's good to know. How many of you use the Transformers library? Okay, that's also good to know. I am not from the Transformers team. I work on the Diffusers library, which is particularly suitable for generation of videos, images, and audios. So in a sense, it's very similar to the Transformers library, but we have got different objectives, we have got a different community, we have got a different audience. But this talk is not particularly about the Diffusers library. It's about video generation in a very general sense. So yeah. I'm sure you all have probably seen this video. It was absolutely bonkers when it first came out, and I think it's beautiful as far as quality is concerned. I'm going to be sharing my slides after my talk so that we can focus on the slides. You don't have to click pictures if you want. But coming to the video, I think it's absolutely bonkers. I still think it's of very high quality. And even as a human being, it's a bit difficult for me to depict what the description is all about. But somehow, models like Sora, the video is from OpenAI's model called Sora, it was able to kind of faithfully and truthfully depict what was said in the description, in the caption on the right-hand side. So it's beautiful. I think it's fantastic to be able to even think about it's possible. I think it's very fascinating. Now, coming to the open video generation models, Sora is sitting behind closed APIs. But today's talk is not going to be about closed video generation models. It's going to be about open ones. So coming to some of the open video generation models that we have got LTX, we have got these two little funny creatures. We've got a cat ready to rock up the stage. And then we have got a Dune-like setup. Not bad. I would say not bad. If I had shown you some of the generation results from back in the days, 2023, you wouldn't believe these are from open models, actually, today's open models. So this is all very exciting and fun. And I want to make it explicitly clear that we are not tied to just one single model when it comes to open video generation models. They come in all shapes and sizes. And since we care about their licensing, we care about their memory footprint, and so on, this table will hopefully give you an idea of where we are currently at. For example, the most popular model, fortunately, it's an Apache 2 model. That means we can use it for all kinds of business and commercial stuff. But it also takes a humongous amount of memory, doesn't it? Like about 64 gigs. It's not consumer friendly at all. But somehow it still has got a very nice ecosystem. We continue to see a growing amount of adoption for the 1.2.2 model, probably because folks feel very inspired and motivated to work on it since it's Apache 2. So we have got all kinds of optimizations figured out around the model already. So that's good. I want to also make it clear that these memory calculations are very approximate, and these do not include any kinds of optimizations. So yeah, you can, of course, optimize the memory footprint quite a bit with all the fancy, with all the latest and greatest in the field. But yeah, this is roughly how the native numbers look like. You have got LTX. It takes about 13 gigs. It's pretty consumer friendly. We have got also other models like Mochi, but its adoption has really stalled. So yeah. They come in all shapes and sizes. That should be the takeaway lesson for this slide. Now, you may have also heard about these models, VO, you have got Sora, as we were discussing. You have got Runway, you have got Pika, you have got Kling. So you have all sorts of different models, but these are very closed. These are all closed source in nature. You don't know what's going on. You can only tweak them up to a certain extent. So I hope the motivation behind this talk is fully clear. Now, I wanted to have a disclaimer because this is going to come up at some point in time. The open video generation models that I'm going to discuss today, these are of diffusion kind, or they follow the flow matching objective as far as machine learning terminology is concerned, but we do not have to worry about that too much. There are other kinds of video generation models possible, but those are not covered in this talk because that can get way too exhaustive. Now, I'm trying to give you a very rough understanding of how diffusion models work in practice, so that's why in a jiffy. So I like to think about diffusion or flow matching models as the following. What happens when you take a completely random noise, and what happens when you try to refine it over a period of time. And that's what the infographic is exactly about. We are starting from a completely random noise, and then we are sort of denoising it over a period of time until and unless we are satisfied with the final image quality. And unlike many other models, diffusion or flow matching models are very iterative in nature. You do not get the results one shot, but the quality that you get after a few iterations is something that we all feel very happy and proud about. Otherwise, those cats and the other funny creatures that we showed a few slides back, they wouldn't be possible. So yeah, you can think of the diffusion process as some sort of denoising happening over a period of time. So yeah. And when we try to condition the denoising process with some amount of text, you get funny creatures like this. Like, I think we all can agree that this funny little fur monster cannot really exist in reality. But somehow, these models have an amazing sense of putting together the concepts in a very cohesive and coherent manner. So this is from another open image generation model called Flux. But the takeaway message is, when you try to condition the whole denoising process with a bit of text, you can be really creative. The whole process can feel very liberating in some sense. And let's try to unpack this thing a little bit. Unlike other models, diffusion models are not single models. And this is something I really want to clear right off the bat, because we tend to think diffusion is just a single model. It would be really easy to implement. It would be really easy to optimize and so on. But diffusion models are not single models. Like, in order for me to get from this prompt, a cat looking like a tiger, all the way to a video, it actually includes a bunch of different models, as we will see in some slides next. First, you gotta find a way to embed the text, the prompt, a cat looking like a tiger. You have got multiple text encoders for getting the text embeddings out of the prompt. And then you have got the text embeddings finally coming out of the text encoders. Then you start with some noisy representation. And then you have got a scheduler which does the whole time step math across a series of a few iterations. But these details can be ignored for the time being. And then you have got your core diffusion or flow matching network, which takes as input as the time step, which gives you a sense of which part in the iteration you are in. You have got the text embeddings, you have got the noisy representations, and you sort of invoke the core diffusion network multiple times. You have got refined latents, and then you pass it off to some decoder to get the actual RGB values. If it's an image, you get an image out, or if it's a video, you get a video out. So you see, these are not single models. Don't let yourself misinterpret that diffusion models are about single models. These are not single models. These include multiple different models from multiple different literatures, which is why these are very harder to get into. Let me make it very clear. So yeah, unlike language models, these are not single models. I hope that bit is clear. And current capabilities beyond just text to video, because text to video, text to image, this is all already very liberating. But if we want to extend the use cases beyond just text condition generation, I think some of these possibilities are very cool. Like, for example, maybe you have a reference image which you want to make a video out of. Image to video could be a very cool use case. Then maybe you have multiple reference images and you want to sort of stitch all of them together in a really nice looking animation or a video. From a product standpoint, that can make a lot of sense. And maybe you have some pose that you want the subject in the video to follow. That could be another cool use case. And these are also some of the use cases that I'm going to discuss throughout my talk. So yeah, let's get into some of them. And before I get into the use cases, maybe you are thinking, how do I interact with these open models? That's exactly why I wanted to have a slide on the diffusers library that I work on at Hugging Face. So if you have already used the transformers library, the API might feel the same. You have got the same from pre-trained API, which initializes a state-of-the-art open generation model. In this case, we are using the one video generation model. And then you have got a text prompt, and then you use the model. That's it. It's just 5 lines of code. I have more lines of code on the slides because I care about indentation and code cleanliness. But yeah, you can squeeze it up. It's not a problem. But the problem is, it takes about 47 gigs to run, which is bad. It's not consumer friendly at all, right? That's why we want to. We try to make things as accessible as possible, and we do that by providing quantization backends. We provide different, memory-efficient attention techniques, implementations of those, and we also provide different flavors of CPU and disk offloading techniques that give you many different trade-offs that we will see. Like, you can combine quantization and offloading to use the one model just under 12 gigs. Sufficient enough for you to sort of navigate across the entire landscape. It gives you the ability to sort of try out these models, but still keep your memory requirements at bay. You can apply quantization through simple declarative configurations in the diffusers library. And you can also apply offloading, many different forms of offloading if you want. So you can combine all of these and reduce the memory requirements down from 47 gigs all the way to 11 gigs. So that should already feel very inspiring and motivating, I hope. So yeah, that's like roughly a very cool summary of what I was doing for the past few months. So yeah, but quality can take a hit when you are applying quantization. Let me be clear on that front. So you got to experiment, of course. Now, if I had asked you which one of these is quantized and which one of this is not, let's start with the left one. The left one is quantized or non-quantized? Left one is non-quantized? Is that the rough consensus in the room? Left one is non-quantized? Yeah, indeed. Indeed, but the memory requirement. The right one doesn't look bad either. It does not follow the prompt maybe in certain portions, and there are ways to get around that. But the memory reduction, 3x. You slosh down the memory by 3x. And that's quite a lot of enablement right there. Right? So yeah. Now, let's come to the use cases a bit. Enough of diffusers. I do not want to stick my library whenever I go to a concert. Whenever I go to an event, I do not want to just talk about the library. I think that's very intrusive. So let's come back to the use cases. So you have this cool little cat. you want to generate a video out of it. And the caption would be some summer bees, vacation style white cat. I'm not going to read the caption. You can read it. Now, the video that I'm going to show you was generated with a fairly state-of-the-art open model. It's called 1.2.2. And the video isn't too bad. Quite good, actually. The subject presence is consistent across many frames. The video looks real. The fidelity is good. The quality is good. So I wanted to sort of break the ice by showing you it's not far behind that we beat VO someday, maybe. But the quality is something that we can work with. Something I think we all can agree. And then you have got maybe some multiple images. You want to stitch them into a nice looking video altogether, maybe for some product demo and so on. So you have got a sunglass. You have got this cool breachy robot from the House of Hugging Face. And then you have got this GPU poor cap, because I am GPU poor. I don't have access to H100s, H200s. I'm a GPU poor guy at my core. I want to stitch all of them together in a nice looking video. I want to prompt the model with robot dancing across the beach. Not bad. Not bad either. It was generated with the same family of model, 2.1, not the 2.2 series. So yeah, it's not bad at all. And then maybe you want to sort of mask out some region within your input image, and you want to prompt the model with penguin wearing a tutu skirt, and you want it to dance. Not bad, not bad, not bad. You can find your ways around the motion dynamics. You can improve the motion of the image. You can improve the quality of the image. All of those techniques exist. But I wanted to give you something way more raw and native, just to show you the possibility of their existence. I think that's important, so that you can think of some use cases maybe that may be pertinent to your business. So yeah. And frame interpolation. You have got a starting frame, you have got an end frame, and you want some frames in between to be interpolated. You want the model to imagine wildly. You want the model to get creative. This is my first frame. This is my last frame. I've got some long caption that I'm not again going to read. It was generated with a fairly recent model called FramePack. And yeah, it seems to be following the prompt quite nicely. It seems to preserve the subject quite nicely. It seems to also preserve the frames quite nicely. So all of these things are possible. Yeah. And I want, I think this is one of my favorite use cases. You want the subject in the video to follow a certain pose. Maybe you want your cute dog to stare at someone with a certain pose in its eyes. And I can see how my talk is quickly becoming a comedy show. But I think this is cool. Like, it's also a technically challenging problem. You are asking the model to follow a particular condition and also trajectory. And trajectory-related stuff is highly, highly relevant in robotic planning, in all kinds of robotic stuff, right? And trajectory planning is an inherent property of video diffusion models. So this is good. Is very good. And video generation models can also be used for regular boring image generation. Like, for example, I have got this again a very long prompt, and I've got a beautiful fantasy photograph. So since video models also learn better priors of the world, they learn better physics-related laws and fluid dynamics-related laws. You can also leverage video generation models for just image generation. So that's also pretty cool. In some sense, it feels like a natural emerging property out of video generation models. So yeah. And of course, as tinkerers, as practitioners, we want these models to use for our custom use cases. You want to be able to fine-tune them to maybe emulate some cool effects, or maybe for some subjects it maybe didn't show during its pre-training phase. And yeah, you can go ahead and fine-tune them. Like, for example, in this collage, I'm showing you different fine-tuned version of the COG video model, which I didn't discuss in this talk. But you can actually teach these models to emulate this cool effects called dissolution, 3D effects, cake cutting effects, dissolves, and so on. And the quality isn't too bad either. So I encourage you to check out the Fine Trainers community project that we have been working on that lets you fine-tune some of the models we discussed today in a cheap and memory efficient manner. A bit old, but all the techniques that I discussed today is present in this blog. So if you are interested, definitely check it out. It's a bit old, but the techniques still apply. And where do we stand? I want to give you a chronology as to how far we have come. Now, this is a table from one of the models that we mentioned, SkyReels. Like you can see the bold facet numbers is the current state of the art. And it actually beats the closed source models like Runway, Kling, and so on, as far as instruction adherence, as far as visual quality is concerned. And that's a huge, huge leap, right? And the latest and greatest is 1.2.2. It actually beats Sora, OpenAI's flagship video generation model in many aspects. And it's not long where we see the charts completely getting beaten by open models. So this is very promising. And this is from back in the days, 2023. So you see poor video quality, very, very poor prompt adherence. And just fast forward a little while, we saw the kind of quality a few slides ago, right? Like the quality has improved quite a bit. The prompt following ability has improved quite a bit, and the capabilities in general, they have improved quite a bit. But back in the day, we had like realism aspect missing. The fidelity was quite poor. I hope the examples I showed you today were convincing enough for you to believe that the state of open video generation model is slowly catching up. Like for example, I have taken this demo from 1.2.2, and you can see the improvement right off the bat. Like if you compare these two videos with the ones that we are seeing here, these are extremely, extremely promising. So hopefully this is motivating and convincing enough. But still, the regular limitations lie, like prompt adherence. I would say you should stick to using detailed prompts where you specify the motion dynamics, you specify the shot angles that you want to see in the generated videos. Prompt adherence, motion dynamics, these two problems can be solved by specifying really large prompts as to what you actually want to see in the generated videos. But the video duration problem, it can be painful. And I think works like SkyReels, they approach these problems in a very collective fashion. And with SkyReels, virtually you can generate infinite length videos, which is good. But it's down on your patience as to how far you can wait, because the optimization landscape of video diffusion models is still catching up. It's not as matured as language models. So yeah, and yeah, that's about it. I think I have finished on time. And if you want to get access to the slides, please scan the QR. I'll be tweeting my slides anyway. It was really lovely talking to you today, and if you have any questions, I'll be here throughout this conference, so feel free to catch me, and thanks once again.